Hey, how's it going, guys? This is Joe Intel. Today I just want to take a look at the Denon X4700H and I want to see what does Audyssey really do. I'm going to be taking a look at the Audyssey MultEQ XT32 on this X4500H. Now I do have a X4700H, which is very similar in many ways and different in others. In this particular case, it doesn't really matter because I'm only going to be taking a look at Audyssey, and for that, they're pretty much just the same. We definitely want to take a look at the MultEQ Editor app and see what some of those settings actually do. So to do this test, I actually have my UMic 1 and REW here. I'm going to be showing you the measurements from this microphone and comparing it to what the results are before and after, and with some of the settings applied and turned off. For the speaker, I have the Polk R200, which I really like. You can check out my review of that. So let's just get into it. Right now, let me do a quick measurement of this in pure direct mode, meaning nothing applied. And I know the mics aren't in perfect places, but just keep in mind that it doesn't really matter because I'm not going to move them. Typically, you would be using this at your listening position. Obviously, right now, we have the mics very close, and that's for a reason. We want to try to eliminate as much of the room interaction as possible. By keeping it close, we're getting a better signal to noise ratio, the signal being the direct sound and the noise being the reflection and room interaction. It's not perfect, but for the sake of this measurement, we're actually just looking at the differences. So as long as we can keep stuff the same, it'll still serve its purpose. All right, so I have this in pure direct mode. Let me just run some pink noise and take a quick measurement. All right, so there we have 100 samples. Let me go ahead and just save this, and we will name this Pure Direct. So there it is. Now the response doesn't look great. It's actually a lot better if I were to move this into the center of the room and kind of do a moving mic method. Now the next thing you would typically do when you set up your speakers is you would run Audyssey. So let's go ahead and do that. And here's the mic here. All right, so here we are in the MultEQ app, and it finds the X4700H. I needed to find this one here. There it is. 4500H, and it shows that I only have a front speaker, and that is correct for right now. So just for fun, let's capture the sweeps that it takes. So I actually have to trick it and switch the wires. Alright, actually I had to move my laptop because there's some fan noise. This is an older MacBook Pro, so yeah, I'm going to move that a little bit further away from the microphone so it doesn't affect it too much. Also, the heat generated from this AVR and it being on top is probably not a great idea. So it looks like it wants me to do at least 3 measurements, so I'm going to do that. Alright, so I'm going to go ahead and proceed. So I will turn off everything and just call this test 1. So real quick, let's take a look at what it found here. So it thinks it's a full band speaker. Not quite. Room correction, let's compare this before and after. So you see that's what it thinks the left one was. Let's see how it looks compared to the right one. They should be exactly the same because the mic didn't move, the speaker didn't change. So let's compare that to what REW found. That should be interesting.
All right, so here in the dark green is the measurement from Audyssey, and in the lighter aqua color, this is my measurement from REW. And so you'll see that for the most part down here, they all track pretty well. This is all tracking. This is a little deeper here. The dip here is a little deeper. On the Audyssey one, slight differences here, and a difference here that I notice. But the main difference that you'll notice up on top is above 10 kilohertz. The Audyssey measurement is higher, much higher than what I measured here. And I think the reason for that is that they have the microphone facing up. And when you use the UMic 1, it actually has 2 calibrations. One for if you're going to face it 90 degrees, which is facing up, and another calibration for it facing forward. I had it set for facing forward, so I think that that is the reason for this discrepancy here. It doesn't really matter because I kept the mic the same the whole time, and what we're looking for is the differences in what that mic took. So here in the light green is a measurement that I took using Dirac on the NAD T778, and you'll see that this also has a rising response here compared to my measurement with REW in the red. These are all scaled to match So in the light green, what you're seeing is the measurement from Audyssey, compared to the darker green behind it is a measurement from Dirac. And you see that these track pretty well, except for here, actually Dirac is looking at the tweeter and the highs as brighter than they actually are being read with Audyssey.
By default, it has high frequency roll off 1, mid-range compensation is on, and on the curve editor, that's how it is supposed to look there. So let's see if their predicted measurement is similar to what the actual measurement is in REW. All right, so taking a quick look at this graph, you can see that overall we lost maybe about 6 decibels after EQ. Let me go ahead and do trace arithmetic and do after Audyssey divided by pure direct, and that'll show us what the difference is between these two. So very interesting, not very much difference before and after Audyssey. Weird. Let me double check the settings and make sure that they're all correct. The mistake I made was I had it in pure direct, and it's good to see that it didn't make any changes because that's not what we want when we do pure direct. It's interesting that it knocked it down by 6 decibels, and I think that's so when you change from pure direct to the other modes, it doesn't jump up drastically by 6 decibels. So kind of doing some level matching there. So let's take another measurement here. This is the reference mode. You can see, first thing I'm noticing is like, what is going on here? This is a bump up. I think that it's supposed to be a dip here. So I don't know exactly what's going on here. When we take a look at the two, so this is pure direct, you can tell that reference is definitely smoother, right? So below 400 hertz, this is definitely a better response than what it was, right? Got that little peak there. So it flattened the response across here, but it seemed to make it worse over here. That's kind of interesting. Okay. You also do see that above, let's say around 9 kilohertz, it does drop off the treble response. All right, so just for fun, let's change this to the flat mode and let's see what the difference is between that and reference mode. What we expect to see here after doing the measurement is we're expecting to see a flatter response. So let's see if that's what it is. All right, so looking at the flat versus reference, it's not a huge difference. You can see that there's a little bit less bass here below 300 hertz and above 100 hertz. A little bit of a difference here and a noticeable difference above 15 kilohertz where the reference actually falls off faster than flat. All right, so let's take a look at the difference by doing flat or reference divided by flat. Okay, reference actually for some reason gives a bump right here around 500 hertz. Everything else looks pretty much the same except for that bump. And also, let's see, around, let's say 8 kilohertz, you can see that it does fall off here pretty fast. So 8 kilohertz to 16, maybe a 6 decibel per octave decrease here above 8 kilohertz. All right, interesting, right? All right, so let's go back in here to the MultEQ app and see what the difference is between the target responses. So the default is high frequency roll off 1, and let's try 2 and see what the difference is between those two. I'm gonna go ahead and switch this to this, roll off 2, which looks like a flatter roll off, whereas the other one is more gradual and then it's steeper as you get higher in frequency. Something kind of interesting is that after I send the file from here to the Denon, it automatically switches to reference mode, which tells me that that is probably the curve or the setting that they use whenever you're gonna make adjustments to this. It's probably gonna make it to the reference curve. When we change it to flat, I'm not sure if the settings actually apply, but we're gonna find out. I'm getting kind of a weird error where when I change it over to flat, I don't get sound coming in. So let me change it back to reference. And that looks right. It looks right. Where they say it's gonna roll off is about right. And so just so you guys know, the roll off for setting 2 looks to start around maybe 4 kilohertz, I would say. 4 to 8, and maybe it looks like maybe a 3 decibel roll off, just straight down, just a straight line. Whereas the other one is more gradual and tends to get steeper as you go above 10 kilohertz. The next thing I'd like to try is turning off this mid-range compensation, the little BBC dip, or what people like to call BBC dip. I don't know if that's exactly what it is, but let's go ahead and turn that off. It's on right now, and see what that does. And so what it does is exactly what it looks like in the picture, which is it takes a little bit of a dip here between, let's say, 1.5 kilohertz to 3 kilohertz, with the center being at 2 kilohertz. And what is this amount? I would say this is, all right, about 3 decibels. So not huge, but yeah, they argue that this is something that sounds better, and I don't know that that's 100% true, but yeah, some people say it sounds good, some people don't like it. Personally, I don't. Okay, so the next thing that we can try is, let's try the curve editor and see if the curve editor is editing the reference curve or if it is adjusting the flat curve. All right, so looking from this, it makes it seem like I am editing the flat, but I think this is actually editing the reference curve, but we'll find out right now. So let's do this. I'm just going to huge dip here. That should be obvious. Let's put a bump here at 5 kilohertz. Real narrow, real obvious. All right. So as you can tell, what we're testing is just the frequency response. We're not testing phase or anything as far as time alignment. Maybe we can do that in a future video, but for right now, this is good enough. It's weird, it just loses it sometimes. Kind of frustrating. And I think other people have had this experience as well. All right, power cycle. And all right. So this is the difference, and those look about right. Those are the changes that we made. So that looks like it's working just fine. All right, very good. Now let's see if this actually applies to the flat curve as well. All right, so let's compare this flat curve to the previous flat curve. And you can see that other than the mid-range compensation, they look the same. So mid-range compensation does apply. I believe that the high frequency roll-off, does that apply? We did change that and it doesn't look very different. Actually, no. Yeah, so only the mid-range compensation applies to the flat. Also, when you're editing in the curve editor, that's only applying to the reference curve. So if you're thinking that it's starting from flat and you're making your own adjustments, no. It's actually their reference curve and then you're making adjustments to that reference curve. And the interesting thing about this is, let's take a look again. Reference versus flat. And let's take a look at the difference over here. Yeah, I don't know what this thing is. This little bump here, it's kind of strange. So this is the main thing that I'm noticing, along with the reference curve having more of a roll off. So if you wanted to undo the reference curve so you can kind of just do your own edits and have that edit a flat curve, you have to undo what they've already done here. So unless this spike around 500 hertz is just some weird something that happened here and it's an error, I'm not sure. Maybe I can do another test, but let's take a look here. Let me see if I'm seeing that 500 hertz in the other reference. Boom, so there's that versus flat. Doesn't have that. And let me see in the second one that I did in the other ones. No, I'm not seeing that in the other one. So that looks like just a weird artifact. Yeah, let's just ignore that part. Other than this, let's just say that this is, you know, some kind of reflection that I'm getting here. Quite possible. So if you wanted to undo what they've done, you're going to want to implement a curve similar to this here, which is basically, again, above 8 kilohertz, you're going to want to include this increase, this rise here to about, looks like about 5 decibels actually. 5 decibels up from 8 kilohertz and up, but it has to be a gradual upward slope. All right, interesting stuff. All right, let me go ahead and clear out these weird edits that I did here, And the last thing I want to test is I want to test the dynamic EQ, and let's see how the sound changes as I turn the volume up and down. Alright, so right now dynamic EQ is set to on. It's set to the default 0 dB. So let's see what that does. Alright, so as a quick snapshot, let's go ahead and compare this dynamic EQ. So when we compare these two, you can see that the dynamic EQ at this particular volume has bumped up the bass. It has also bumped up the treble as well. So the bass and treble, it's bumped up, and it looks like it's hinging at around 1 kilohertz, somewhere around there. Let's take a closer look by looking at the difference. Alright, so you can see what it's done. It's given it kind of a little bit of a smiley face with an increase here in the bass of a decent amount. That looks like about 8 to about 9 decibels here in the bass, and here 0 decibels throughout this range from 1 kilohertz up to 3 kilohertz, and then above that it starts to rise, maybe it looks like about 5 decibels here. 3 to 5 decibels, 4 decibels increase in the treble. So that's interesting. That's at this particular volume. Now let's see if that changes if I turn it up and down. Let's see what happens. What I'm curious about is, let's see if it's a difference if I change the volume at the source versus if I change the volume here on the AVR. It seems that if you change the volume at the source, that it doesn't adjust the EQ dynamically as opposed to adjusting it here. Now the question is, if that's based on loudness, what happens if your source volume is different? So maybe something to consider there. I'm not sure how they handle that, but I assume that there's a reference volume that they need to understand going in for them to adjust according to perceived volume, because they have to know what the actual volume is. You know, if it's just based on the dial here, well, if your source is a totally different input volume, then that could throw things off, and that might be why for some people it's just too bassy. They're like, oh, that's too much bass. Or for some people it's like, it's too weak. Maybe it has to do with their input signal. I'm not sure. Usually I turn this feature off. It's not something I like, but yeah, that's up to you. Let's do a test to see what happens when we change the volume here. Interesting. So when we did minus 30 dB on the computer versus the same volume, but using this volume knob here, you can see that at lower volumes, it chose to keep the bass up significantly higher. I would say this is 71 versus, what's the other one? 70. So 77 versus 72.6. So about 5 dB difference. Yeah, below 200 hertz, below 100 hertz. Even here, you'll see a lot more difference. So it's definitely bumping up the bass. Treble, you can't tell as much, maybe a 1 decibel difference, so nothing drastic there. Let's see what happens when we turn the volume up. When you turn up the volume, here it starts to flatten out the response. It doesn't give it that same bass increase. Actually, compared to turning it up just on the source itself, the bass is actually down a few decibels. Let's take a look here. We're looking at 90, about 3 decibels down, again from 200 hertz and below. The treble is about 2 decibels higher when you turn up the gain on here. So what that's telling me is it's really dependent on the input volumes. So, you know, when they're doing this dynamic EQ, I hope that they understand what the input volume is. They might, but just something to consider. If it's something where you can change the volume on the input source, maybe this is the reason why people are giving such varying differences in how Audyssey sounds to them. All right, so I'm still very curious as to why it seems to give this spike here after it does its correction here at, you know, around 3 kilohertz. I'm not sure what this is, so what I'm going to do is I'm going to actually not turn it to pure direct, but I'm going to just turn it so that you have the reference, you have flat, and then you have off. I'm going to change that to off and see what the measurement is on this. So from what I'm seeing, having that set to off and pure direct is giving me the same response, and it's the same as the one I got previously. Now let me go ahead and turn on reference one more time and see if I'm seeing that same spike. It's kind of weird. Yeah, so definitely what I'm seeing is after the calibration, after Audyssey does its thing, it does have these two spikes here at, what is this, about 2.6 kilohertz, and another one centering around 3.4 kilohertz. Now I'm not sure why they do that. Maybe it was an error in the correction here. Maybe it's the way I had it set up, or maybe it's done on purpose because perhaps there is a theory that when you're listening to stereo left and right without a center, then you're gonna get some kind of a dip in the response, maybe around this frequency here. It's just kind of odd that they'd put a spike there and then use mid-range compensation to scoop that out a little bit in that region. Yeah, I'm confused. Let me know in the comments if you guys are finding the same results in yours. This could be the reason why, for me, I feel like Audyssey is a little bit harsher than when I use Dirac. So Dirac, I don't know. But maybe I can do the same test with Dirac and see what it does, and maybe kind of keep this in the same position and see what kind of corrections it does in comparison to Audyssey. So anyway, I hope you learned something. I know I did. I find this fascinating, and I will leave the MDAT file, meaning if you have REW, you can actually look at this file yourself and come to your own conclusions. Maybe leave them in the comments below and see what you find. Let me know what you guys think. If you like the video, make sure to like, subscribe, ring the bell to be notified when I upload new videos. Take care. Bye-bye.